Okay, now the wheels of a car are of diameter 80 centimeter each, right? How many complete revolutions does each wheel make in 10 minutes when the car is traveling at a speed of this? So basically here time is given, right? Which is like 10 minutes. So you have to consider only 10 minutes here. And speed during these 10 minutes is given, which is 66 kilometer per hour. These two things are given. And then you have to find the number of revolutions, right? How do you find the number of revolution? See what is happening here. You have a wheel. Try to understand this. Correct, Harsha? Rida? See, you have a wheel. Okay, let's put a dot on this wheel. Let me say I put a dot here. Am I audible?
Yes, ma'am.
Okay. So,
Yes, ma'am.
okay. So now let uh, just consider it as a circle. So let us say I just cut the circle here and I expand it in the form of a band. What will happen here? So this end will it will go here, it will go here, and it will somehow come here. Isn't it? It will become like this. Understood?
Yes, ma'am.
So basically this circumference of the circle, I'm just converting into a strip. So let's say uh, this is the strip. I just cut it here and I just take it here. So that means in one revolution, this much distance is covered. Is that okay? Revolution means one complete round. Understand, Harsha?
Yes, ma'am.
So this was the starting point and I just cut the circle and I just convert this into a strip. So that means this is the length which will be covered in one revolution. Understand? Okay.
Yes.
So there, how will I find number of revolution? So let's say this is some distance the car has covered from here to here. Let's say this is the distance the car has covered, right? I want to find number of revolutions here. So let's say this length, which is covered in one revolution, let's say this is something 3 centimeter or 3 unit, right? So how will I find the number of revolution? I'll just, let's say this is my first 3 unit, right? Then this is my next 3 unit. Then this is my next 3 unit. This is my next 3 unit. And this is my next 3 unit. So I'm seeing that 1, 2, 3, 4, 5. That means the wheel has to make 5 revolutions to complete this distance. Understood?
Yes, ma'am.
Yeah, so this is the approach in this question. So you have to find the number of revolution. That means, first of all, you will find the complete distance which is covered by the wheel in 10 minutes. Only 10 minutes you have to take, right? Got it, Rida? Okay, so first of all, let us find how much is the total distance covered by this car in 10 minutes. Okay, now there's a problem here. The time is given in minutes and the speed is given in per hour. So how can I write this? I can write 66 kilometer per hour mean this hour will come in the denominator. Understand? Okay. Now you convert this kilometer into centimeter. Why centimeter? Because in the question centimeter is used. Got it?
Yes, ma'am.
Right? And if you want to use, you can simply use this, which I told you. Milli, centi, deci, meter, deca, hectare, kilo. Right? So that means you are going towards a small unit. So you will multiply. So how many? 1, 2, 3, 4, 5. 5 0 you have to multiply. So that means 66 into 10 to the power 5. Now it will become centimeter. Understood?
Yes, ma'am.
Okay. Now R. So R, that R means it is 1 hour, right? If you want to write this in minutes, so 1 hour means 60 minutes. Is that clear?
Yes, ma'am.
Okay.
Ma'am, but why do we have to convert kilometer to centimeter?
Mm, see, because the diameter is given in 80 centimeter. You cannot use different units in calculation. Either you convert your diameter into kilometer or you convert your kilometer into centimeter.
Okay.
Yes.
Yes.
Okay. Okay. So distance covered by the car in 10 minutes. Let us find this. Or you can say total distance covered by the car, let's say. So, distance is equal to speed into time, right? Okay, so speed is how much? Now we have got 66 into 10 to the power 5 and then divided by 60. So 66 into 10 to the power 5 and then divided by 60, right? Now this is in centimeter and yeah, so this is in minutes. Okay, that's it. And then into time. Now time is 10 minutes, correct? See why I'm not converting this. Now you can ask one question. Why I'm leaving this in minutes? I can convert it into seconds also, right? So I'm leaving
Yes.
this in minutes because in the question the time is given in minutes. So I have to keep the unit same. Okay.
Okay.
Yeah. So now this I got. Now if you consider it as a unit, for example, so you can see now minute actually cancels out, right? And the answer is going to be in centimeter, which should be because it's the distance you are finding, right, Vida? Okay, now just simplify. So 66 into 10 to the power 5, if I write 1 2 3 4 5, and then there's one more 10 and then you have 60, right? So that means 1 0 cancels out and this will become 11 into 1 2 3 4 5 0, and yeah, obviously in centimeter. And yeah, just put 50 1 2 3 4 5 centimeters. So this is the total distance covered by the car in 10 minutes, right?
Yes, ma'am.
Okay, now we find the distance covered in one revolution. So now distance covered in one revolution means circumference of the circle of the wheel or circle. Is that right, Rida? So one revolution means if you have a circle, so you put a dot. So you want to see after how much distance the dot will come at the same place. So the dot will move like this, will move like this, will move like this, it will come here. So this you can convert in the strip. Just cut the circle here and just take this dot here, here, here. So it will come somewhere here. So that means this is the distance covered in one revolution. Understand? So this length is actually nothing but the circumference of the circle, which you know, which is 2 pi r, correct?
Yes, ma'am.
Okay. So 2 into pi, you can leave it in pi for the time being. How much is radius of this circle? Diameter is given. So radius
Okay.
is 80 by 2 centimeter, right?
Yes, ma'am.
So 2 cancels out. So 80 pi centimeter is the distance covered in one revolution. Okay. Now you have to find the number of revolutions. So number of revolution means total distance covered and then divided by distance covered in one revolution. Is this understood, Rida? How I got this formula?
Yes, ma'am.
Yes? Okay. So just put it, I've already found. Total distance was 11 and then 50. So 1, 2, 3, 4, 5, and it was in centimeter. Now this distance is 80 pi. This is also in centimeter. Obviously, because you're finding number, yeah, right? So you will get a number. That means no units. Okay. So all the units should cancel here. Okay. So only a number you will get. That's it. 1 0 if I can cancel, right? So this is 11 and then 1 2 3 4 0 now divided by 8. Now you can put pi. So pi is in denominator. So 22 will come here and then 7 will come here, right? No units.
Yes, ma'am.
Okay. So 11 into 2 is 22. So if I divide all this by 11, so the numerator will be 1 and then 4 0. 1 2 3 4 into 7, right? And then 8, and this will be 2 times. Is that clear?
Yes, ma'am.
So you have to disturb the zeros now, I think. First of all, divide this by 2. So it will be 5 and then 1 2 3 0 divided by 8 and then into 7. Okay. Now again from 4 directly you can divide if you wish. So 4 into 1, then 10. 4 into 2, then 20. So 4 into 5. Okay, and then divided by 2 into 7. Now again from 2 you divide 2 into 6, 2 into 2, and then 5 into 7, right? Now just multiply. 7 into 5 is 35. 3, 14, 17, carry 1, 42, 43. So 4375 is the answer. It's the number of revolutions.
Ma'am, after the surface areas and volumes chapter, the first chapter you took is this one.
Sorry, what are you saying?
After that chapter, like, did you do any chapter before this?
Before this, we were doing revision, right?
Yes,
Arithmetic
ma'am.
progression. And before that, which chapter we did? Yeah, surface area and volume, I think.
Yes, ma'am. So after the revision, you just took up this chapter, right?
Yes. So this is a
Okay.
new chapter I've started. Yeah.
Okay.
Yeah, because only three, I think after this, I think only 2 chapters are remaining now.
Yes.
One is circles and the other is, yeah, what's the next one?
Construction.
Construction is not in the syllabus.
Okay.
Statistics is remaining. So after this chapter, you will be left with circles and statistics. That's it.
Okay, ma'am.
Yeah. So we will have enough time for revision if you wish. We can solve some, model question papers kind of things. So I'll get one for you, and then one by one we will solve all the model question papers. Okay.
Ma'am, after this, can we have like a revision for trigonometry?
Yes, we can do that. No issue.
Okay, ma'am.
Yeah, we will solve some extra. I'll prepare an assignment, so we will solve it together in the class.
Okay, ma'am.
Yeah, or some RD Sharma exercises we can solve. I think that's a better idea. Already questions are in front of you,
Okay,
so
ma'am.
simultaneously we can discuss also. Yeah, okay, let's do this one. Just 1 minute. Area of sector. Yeah, okay. Okay, fine. Now next question quickly. Now take the correct answer in the following and justify your choice. Okay, if the perimeter and area of a circle are numerically equal, okay, then the radius of the circle is, okay, no problem. So the perimeter, that means 2 pi r, right? This is equal to area of the circle, which is pi r square. Clear? So
Yes,
you have to tell what should be the value of r here. So if you just solve it, so pi cancels out from both sides. So here only 2 will left. 2r is equal to r square. Now 1r will also cancel. So 2 is equal to r. So r is equal to 2 units. Yes. I mean, you can also check like this. If the perimeter is 2 pi r, right? So you put 1 by 1. So first value I'm putting, put r is equal to 2. So what you get? 2 pi and then into 2. So you get 4 pi, correct? Now pi r square. So if I put r is equal to 2, what will I get? So I get 2 square, which is again 4 pi. So that means for this value of r, my perimeter and my area is equal. Obviously, for the rest of the three option, you will not get this thing. So the correct answer is A.
okay, ma'am.
Now next topic here. Okay, so far we were doing perimeter and area of the circle. So there's a new thing which you have to study is the area of the sector. Now what is a sector? So area of sector and area of segment you have to study. So if you have a circle, right, which has a radius O. So if I just cut a piece like this, it's like a piece of cake. So this part is called the sector. Understand?
Yes, ma'am.
Okay. And obviously this is minor sector, right? So this one is called minor sector and the remaining part will be your major sector. So the circle is being divided into two sectors here. One is minor sector, one is major sector, right?
Yes, ma'am.
Okay. Now there's another thing. If again you have a circle, sorry. Yeah, this is the center O. So I'm not touching O. I'm just cutting a circle, something like this. Let's say this portion I'm cutting out. Now what this portion is called? This is called segment. And obviously this is minor segment. And the remaining portion will be called as major segment. Yes, Hamna? Yes, Hamna, can you hear me? Okay, anyway. So now you can note formula for the sector. So area of sector is equal to, so here there's one thing you should, this theta has to be given. If you know this angle theta, then you can find the area of the sector. Okay, so this is theta by 360. So 360 is the complete, what do you say, complete angle, right? Theta by 360 into pi r square. That's the formula. This is the area of the sector. Okay, let us come to the area of the segment. So see, I'm going to derive this area for you so that you should know how you are getting it. You don't have to like remember the derivation, but just once I want to show you. Okay,
Okay.
so at least you will get an idea. So let me take this segment here. This segment, I want to find the area. This is the center O, and let me call it PQ. Okay. Hmm. See, I can find this shaded area like this. If I already know the area of this sector complete OPQ, right? So if I find the area of the sector and then I subtract the area of the triangle, so I'll get the shaded part.
Yes, ma'am.
Okay. Now area of sector formula I already know. Now I want to find the area of this triangle. Let's say this is my triangle O, P, and Q. So there's a problem. I know only this, that this is theta. That's it. I don't know any of the side.
Ma'am, we won't
Mm.
be given by the radius.
Mm, okay, you will be given, let me call it R. I'm not putting any numerical value. So you know the R and you know the theta, right? And the formula you know is half into base into height, correct?
Yes, ma'am.
Okay. So you don't know the base, you don't know the height. That's the problem, right?
Yes, ma'am.
Hmm. So I can do one thing here. I can just, drop a perpendicular. So I just divide this triangle into two equal parts, right? So this angle will become theta by 2. This is also theta by 2, right? Okay. Now I can use trigonometry. If I want to write, let me call this L, right? So if I write cos theta by 2, cos is what? Base upon hypotenuse. Is that clear?
Yes, ma'am.
So base will be my side, uh, OL. Is that clear? Because I'm taking this theta, Rida. Is that clear?
Yes, ma'am.
So because I'm taking this theta, this theta, so OL will be the base and hypotenuse will be OP. Is that clear? Okay. So OL I want to find. Basically OP I know, which is R. So that means cos theta by 2 is equal to OL divided by R. Sorry, yeah. So this implies that your OL is R into cos theta by 2. Is that clear? Okay, so at least height of the triangle I have got, which is OL. So this was OL, right? Base means I need PQ. Clear?
Yes, ma'am.
So at least half I find PL and then I'll multiply by 2. Now for base, I can find sine theta by 2, right? Sine will be perpendicular by hypotenuse. So if I'm taking this theta, so that means PL is the perpendicular and then hypotenuse is OP. Is that understood?
Yes,
Okay. So sine theta by 2 PL, I want to find OP is given, which is R. So now this implies that PL is equal to R into sine theta by 2, right? Okay. So now area of triangle OPQ is half into base into height, right? So half into base is PQ into height is OL, right? Okay. So this is half into. Now PQ is double of PL, correct? So that means 2 times of PL you can write into OL. Now just put values. So half into 2 into PL is R sine theta by 2 and OL is R cos theta by 2. Understood?
yes, ma'am.
Okay. So this 2 cancels out and you get R square into sine theta by 2 into cos theta by 2. So this is the area of the triangle I have got, right? So basically now there's a circle and there's a sector and then there's a triangle. This is O, P, Q. So now I have got the area of this triangle and I want to find this shaded region, right? So that means area of segment. Now how to name a segment? If I simply write PQ, PQ is a chord, it's not a segment, right? And then how will I differentiate whether it's a minor segment or a major segment? So no problem, just any point you can consider. Let's say this is any point you can write R, you can say. So you can name it PRQ, like this you can name it, right? So, right, PRQ.
Yes,
This way you can identify. So area of segment will be, as you know, area of sector OPQ and then minus area of triangle OPQ. Correct? Area of sector formula, that is theta by 360 into pi r square. And then this area we have found r square into sine theta by 2 into cos theta by 2. So this is the formula for the area of the segment. So this is a formula actually, right? You have to remember area of segment. Now now it's clear that from where you are getting this formula, right? So the picture is clear in your mind that you are actually doing area of sector minus area of triangle. Understood? Sector you already know. Area of triangle is if this is the angle theta, then this is sine theta by 2 cos theta by 2. So you will use this formula when only theta is given and nothing else is given. Now in some questions height might be given, so you can directly write half base into height, no problem. And if height is not given, you only know the radius of the circle, that's it, and theta. So you can directly use this. I hope it's clear.
Yes, ma'am.
Okay, let us do exercise 12.2. Okay, it's very straightforward question that find the area of the sector with radius and angle is right. So radius is 6 centimeter and theta is 60 degree. Angle of the sector. So area of sector you find theta by 360 into pi r square. Now please put the values and tell me the answer quickly. Yes, what is the answer?
Ma'am, 182.28.
Okay, you can leave in fraction. I think in NCRT it's given in fraction.
Okay, ma'am, 132/7.
Yeah, that's right. Yes, Rida, have you got it?
Yes.
Okay. Hamna, I cannot hear you. Please say something. Is she in the class or not? Let me check. Yes, Hamna, please unmute yourself. Anyway, next question now. See, when you people say yes, so I assume that you are doing, right? Um, it's on you. Like you have to do it simultaneously with me. Find the area of the quadrant of a circle whose circumference is given, right? So circumference is equal to 22 centimeter. So that means 2 pi r is already given, which is 22 centimeter, right? Okay. So you can find r from here. So r will be 22 divided by 2 pi centimeter. Clear? And if you want to divide, you can write this 11 divided by pi centimeter. That's your r. So leave it in pi. Now you have to find the area of the quadrant. So quadrant you already know, right? If you divide the circle into 4 equal parts, so these are called quadrants. That means 1/4 of a circle. So you already know from trigonometry, this is first quarter, second quadrant, third quadrant, fourth quadrant. Clear? Okay. So that means one of the quadrant area you have to find. How much is theta? How much is the sector angle here? Come on, what will be the theta here?
Ma'am, 25?
Okay, now you can do this in 4 parts. You can consider it as a, sorry, by 2 methods. Either you consider it as a sector, okay? If I call it A, B, O like this. So area of quadrant is actually equal to area of sector. So quadrant is nothing but one of the sector of the triangle. Clear? Which the formula is this, theta by 360 into pi r square. Now there's another way of doing it. So area of quadrant is nothing, it's just 1/4 of the area of the circle. Yes, Harsha? Both way you can. Yeah, so both way you can do it. So anyway, this you can complete. Now I was saying if you consider it as a sector, so what should be the theta here? 90, yeah, okay. Because you are dividing 360 into 4 equal parts. So this angle is always 90. So this you will use 90 by 360 into pi r square. So 0, 0 cancels out and this will be 9 into 4, right? So 1 by 4 into pi. Radius is 11 by pi. So 11 by pi into 11 by pi, hence centimeter square. Clear? Okay. So 1 pi cancels out and you have 11 into 11 is 1. Okay, leave it 11 into 11. And now you have 4 and then 1 pi in the denominator, right? Okay, so 11 into 11 now divided by 4 into pi. So 22 into 7, right? Yeah, I think 1 pi cancels out. Okay, fine. And yeah, so 11 into 2 at least you will can do. So 11 divided by 4 into 2. And yeah, one more 7 is here. So this will be 77 divided by 8 centimeter square. You can leave it like this in fraction. So I hope it's understood. Both way you will get the same, right? If you do 1/4 area of circle, that also will give you the same answer. Okay, now see here. The length of the minute hand of a clock is 14 centimeter. Okay. Find the area swept by the minute hand in 5 minutes, right? So you have a clock like this and only one hand you have to consider, that's your minute hand. So these are the numbers. Let's say this is 12 and this is 1. So minute hand, you already know that from here to here it covers 5 minutes, correct? So you have to find the area swept by minute hand in 5 minutes. That means this area of sector you have to find. Clear?
Yes, ma'am.
Yes. Okay. What is given here? Length of the minute hand. So that means the radius is already given. Clear? This is 14 centimeter. Now theta is not given. You don't know what is theta, right?
Yes, ma'am.
So how will you find? Can anybody tell me? Any guess?
There'll be like 12 divisions. So if we divide 360 by 12,
Hmm. Yeah,
yes,
that's good. There'll be 12 division, or you can do unitary method also, right? So theta, you can say theta subtended in 60 minutes, like total, one round. That means the angle will be 360-degree. Clear?
yes,
Theta subtended or angle covered, you can say angle covered in 60 minutes is 360-degree. So you find your theta subtended in 1 minute, right? So in 1 minute, it will be 360 and divided by 60, right? And now you have to find this in 5 minutes. So theta subtended in 5 minutes. So you multiply this by 5. So 360 divided by 60 and multiply by 5. So this much will be the theta covered in 5 minutes, which you can simplify. Oh, sorry. It was 60 in the denominator. Okay. Which you can simplify. So 0 goes, and 6 into 6 is 36 and 6 into 5 is 30. So 30-degree is the angle covered in 5 minutes. Yes, Rida, understood? Yes, Rida, understood? Okay, I hope it's clear. So you have got your theta, which is,
Yes, ma'am.
yeah. So theta you have got, which is 30-degree. Now quickly find the area of the sector. Or you write like this, area swept by minute hand is actually area of sector, right? So that's theta by 360 into pi r square. Now please put the values and find it quickly.
ma'am. 154 by 3.
Okay, please check at the back of NCRT. I think it's correct. Rida, are you also getting it? Please check your answer. Next question. A chord of a circle of radius 10 centimeter. So there's a circle whose radius is 10 centimeter. Okay. Find the area corresponding minor segment and major sector. Okay, so there is a chord, somewhere you have a chord. Okay. And the radius of this circle is 10 centimeter. Subtend right angle at the center. So this angle is given, which is 90 degree, right? Okay, find the area corresponding to minor segment. Minor segment means this shaded area you have to find. Clear? So again, you can name it like this, A, B, and just put one point here. Let's say C, and this is O. Use the formula that area of minor segment is equal to this, which is area of sector OACB, right? And then minus area of triangle OAB, right? This theta by 360 into pi r square, and then minus area of triangle, which we have found, r square into sine theta by 2 into cos theta by 2, right? Now in the question you have to use pi 3.14. So we will put the, well, yeah, okay, there's only one pi, so you have to put it. And theta is given, which is 90 degree. So 90 divided by 360. Pi you have to use 3.14. Radius is 10 centimeter. So 10 centimeter into 10 centimeter. Okay. Now minus, again radius is 10 centimeter into 10 centimeter into sine of theta by 2, right? So sine of 90 by 2 into cos of 90 by 2, right? So 100 go, and this is 1 by 4 into, if I remove the decimal, so it is 314 divided by 100. And then you have 10 into 10 is also 100 centimeters square. And then minus, this is 10 into 10 is again 100 centimeters square. And this is sine of 45 into cos of 45 degree, right? Okay. So 100 here cancels. This is just 314 divided by 4, and then minus, oh sorry, 10 into 10 is 100 again here. So this is 100 into, how much is sine 45? 0, half, 1 upon root 2, correct? So this is 1 by root 2. Cos 45 is also 1 by root 2. So 314 divided by 4 minus, and this is 100 divided by root 2 into root 2 is 2, right? Okay, then take LCM, right? Only one time we will do the division. So take LCM, which is 4. So this is 314 and minus. So it will become 200. So this will become 114 divided by 4, right? And now just divide by 4. So 4 into 2 is 8. Then you have 34. So 4 into 8 is 32. And then you have 20. So 28.5. Obviously, centimeter square. Is that understood? Yes, Harsha, is that understood?
Yes, ma'am.
Okay. Now look at the second part of the question. Then you have to find the area of the major sector. There is no problem. Just find the area of the minor sector and then you do area of circle minus area of minor sector will give you the area of the major sector. Clear?
Yes.
So can you complete this second part if I leave?
Okay, ma'am. Ma'am, just can you scroll down a bit?
Sure. The second part will be area of major sector is nothing but area of circle and minus area of minor sector. So area of circle, you know, pi r square, and minor sector formula, you know, theta by 360 into pi r square. So you can simplify like this, pi r square minus theta by 360 into pi r square, right? Before putting the value, just simplify the formula itself. So pi r square you can take common. So this is 1 minus theta by 360. So just put the theta here, pi r square, and then 1 minus theta is 90 here, right? So 90 by 360 is again 1 by 4, right? So this is 4 minus 1, which is 3. So this is 3 pi r square. Now you just put, so 3 into 3.14, and then radius is 10 centimeter into 10 centimeter. So if you remove the decimal, you'll get 100. Both the 10 will cancel out. So you just have 3 into 314 centimeter square. And this is 3 into 4 is 12. Carry 1, 3, 4, and 9 for the 2 centimeter square. So I hope the calculations are correct. If you can check the answer, or if there's a mistake, you can just go through the calculations again.
Can you just scroll up to the first part?
Okay.
Ma'am, can you scroll down?
Hmm. Yeah, sorry, I'm just forgetting this 4 here in the denominator. There's a 4 also, right? So after taking LCM, you'll get a 4 in the denominator, correct? So this is nothing. 942 divided by 4, which you can simplify. 4 into 2 is 8. Then you have 14. 4 into 3 is 12. Then you 22. 5 into 20. This is the area of the major sector. Okay, then I'm leaving on this question now. Yeah. Can we have a test on Saturday?
For which lesson?
So till now, chapter I should take. I think I'll take this chapter only, the portion which I've already covered, only that much, based on the first exercise. Okay. So
Okay.
let us stick to one chapter right now.
Ma'am, like the first exercise only.
Yeah, and I think area of sector also I'll give you at least the simple, very simple questions I'll give.
Okay.
Okay. Okay.
Okay.
Okay then. Bye.